6.6% in probability. You've all seen the percent symbol before. You might not remember exactly what it means, but the simplest phrase possible is really, it means parts per 100. So for example, 25% means 25 over 100, which is the same thing as 1 over 4. These are all the same thing. Percents can be used when talking about probability, which simply put is the study of the probability, the likelihood that something is going to occur or not occur. At one end, you have a probability of 0, which means that it's impossible for that event to happen. At the other end, you have probability equaling 1, which means that the event is definitely going to happen. In the middle, you have a percent or a probability that many of you have seen before, 50% chance of happening, which means there's an equal chance that that event will happen or won't happen. As you move to the right, the probability of the event happening goes up, and as you move to the left, the probability that that event will happen goes down. This is the formula that is most important in the section. It's really important that you know it, which is the theoretical probability P. The probability that something will happen, theoretically, is the number of favorable outcomes over the total number of outcomes. And the number of favorable outcomes is going to be totally defined by what the question is asking. So let's do one. You toss 2 coins. What's the probability that both are heads? This is our favorable outcome. So let's count the number of ways, the number of outcomes, the number of ways the game, quote unquote, can't see my hands, but quote unquote can be played. Here's coin 1, here's coin 2. How many different ways can you flip these coins? Well, you can end up with heads and tails, tails and heads and heads, or tails and tails. There's no other outcome. So how many outcomes do you see? There are 4 of them. 4 outcomes. So our fraction is going to be over 4, which correlates to the total number of outcomes right there. You want to know the number of favorable outcomes. So the favorable outcomes are both heads. How many different ways can you get heads? Well, there's only one way. So the probability that you will get 2 heads when you flip 2 coins is 1 out of 4, which equals 25 out of 100, which equals 25%. So the percent chance that 2 heads will come up when you flip 2 coins is 25%. You need to count the total number of ways you can play the game and count the number of favorable outcomes. If you know those 2 things, you can find the probability of something happening. What happens if you had an algebra class with 17 boys and 16 girls? One student is chosen at random from the class. What is the probability that the student is the girl? Well, how many different students could be chosen? Well, there are 17 plus 16 students. This is the number of possible ways the game could be played. You could pick one of the 17 boys or one of the 16 girls. You have an equal chance of choosing any of the students. The favorable outcome in this case is the student is a girl. How many different choices are there for a girl? There are 16 of them. So the probability that you choose a girl is going to be 16 over 33. Probability of choosing a girl. As a side note, what's the probability of choosing a boy? Well, that's going to be 17 over 33. You'll notice that's the probability of choosing a boy because you have the same number of students, but there's more boys. The key thing to notice right here is that 16 over 33 plus 17 over 33 is equal to 33 over 33, which equals 1. If you add together the probability of every possible outcome happening, it should always equal 1. If it doesn't equal 1, it means you haven't accounted for one possibility. In this case, all the students are either boys, a boy or a girl. A given student is either a boy or a girl. So let's do a survey question. It says, use the circle graph at the right. Use the circle graph at the right showing the responses of 500 teens to a survey asking, where would you like to live? If you were to ask a randomly chosen teen, so this means you have an equal chance of choosing any of the teen of the 500, what is the experimental probability that the teen would say large city? So how many different possible outcomes are there? There are 500 students you could possibly ask. And the favorable outcome in this case corresponds to large city. So that's going to be 155 out of 500. Simplifying this down, divide everything by 5, you're going to end up with 31 over 100, which means there is a 31% chance the randomly chosen student will say large city. For small town, it would be 90 over 500. For suburbs, 100 over 500. Rural ranch, 70 over 500. And wilderness, 85 over 500. As I said before, these are all the possible outcomes. There are no other possible outcomes. So if you were to add together 31 over 100, plus this, plus this, plus this, plus this, it should equal 500 over 500, which equals 1, because you've accounted for all the possible outcomes. But this one in particular corresponds to large city. Now, there's also another way to describe probability, which is the odds of an event occurring. It's a little tricky, so it's important that you really understand what this says. When all outcomes are equally likely, the odds that an event will occur are given by the formula. Odds equal the number of favorable outcomes over the number of unfavorable outcomes. So for example, let's say I gave you the set of numbers 1, 2, 3, 4, 5, 6, 7. If I said randomly choose a number, you could choose any of those 7 numbers, and I could ask you, what are the odds that you choose, odds of choosing a multiple of 3? You first need to come up with the favorable outcomes. How many favorable outcomes are there? Which numbers are multiples of 3? 3 and 6. So the odds of choosing a multiple of 3 are going to be 2, because there's 2 possible ways to choose a multiple of 3, over the number of unfavorable outcomes. There are 1, 2, 3, 4, 5 of them. So the odds of you choosing a multiple of 3 out of this set of numbers is 2 out of 5. So going back to the probability question, the odds that you will choose a number that's a multiple of 3 out of the set is 2 out of 5. But what's the probability that you'll choose a number that's a multiple of 3 out of this set? Remember, that definition is up here. It says the theoretical probability is the number of favorable outcomes over the total number of outcomes. So the number of favorable outcomes right here, there are 2 favorable outcomes over the total number of outcomes, which is 7, because there are 7 numbers in this set. So 2 ways of describing the same event. The odds of choosing a multiple of 3 are 2 out of 5. You would say 2 out of 5. The probability of choosing a number that's a multiple of 3 would be 2 out of 7. And this is a little trickier to put into percent, because it's hard to break down 7. How many times does 7 go into 100? So you could pull out your calculator, and on your calculator all you would do is do 2 divided by 7, and you end up with 0.28571, it goes on, which is the same as 28.57%. So this is the probability that you choose a multiple of 3, and these are the odds. So how do you convert between the two? How do you convert between the two? Well, there's this really important formula right here which says the odds, the probability, the odds are equal to the probability that an event will occur over the probability that an event will not occur. And that's the same thing as the probability of an event will occur over 1 minus. Now this all seems pretty crazy, but if you remember it, it's not impossible to use. So let's go back to this example right up here and really focus on this right here. The odds equal the probability of an event occurring over 1 minus the probability that that event will occur. So we figured out the probability of this event occurring was 2 over 7. So let's plug that in right there. Plug 2 over 7 into probability of an event will occur. So that's going to be 2/7 over 1 minus 2/7 should equal the odds. So we need a common denominator on the bottom. So that's going to be 7 over 7, which is 1, minus 2 over 7. So that's 2 over 7 over 5 over 7. And dividing by a fraction is the same. Dividing by a fraction is the same thing as multiplying by the reciprocal. So you have 2/7 times 7 over 5, which is, 7's cancel, 2/5. So if you want to convert from probability to odds, all you need to know is the probability that an event will occur. You take that, you plug it into this formula right here, very important, and you will get the odds. There's a lot to go over. I hope you found this helpful. I highly recommend replaying this video.